Sound now? Yep, checking sound now. Sound now? Sound now? There we go. There we go, and Twitter's up. Almost ready to sort in a couple of things. Right, we're back now. So we're almost ready to start. I've got a problem with my computer. I'm trying to figure out. Here we go. I can't remember how. Forgotten, even though I did it last week, I've forgotten how to share my screen. Er, hmm. Can't find that information again. Hmm. Well, we're not going to start with anything just yet. I'm going to try and fix this. How did I share it last time? completely forgotten from last week how to do screen share on Linux. Whoops. So I've totally ballsed it up. I did a lot of stuff in my sort of own time, like not in streaming, with getting the Linux laptop set up. So it's going to be quite different to what you guys were seeing on stream the other day. What was it? Was it? So this is the joy of when Linux goes wrong. Oops. Oh, there's something not quite right because window swapping doesn't work. That ain't good. My 3 is not working properly, so hold on. Hold on. Linux. Screen capture. OBS. HDMI. Linux, screen external. How did I do this? There's like a shortcut for it. Linux, change monitor, mirror. Ubuntu mirror display shortcut. A3AWM mirror display. Access Ubuntu settings. Desperately trying to find this. Okay, kind of got it. Not quite. Uh, not quite what I wanted, but hold on, try this. I'm just wondering now. I've got two polybars going on. I want to get rid of one of them. I'm not sure why there's two of them there. Just keeps launching two of them. Almost got this back up and working, but trying to figure out why the resolution's not good. Oh, I just realized my thing's really stretched. That's annoying. That can't be right. Almost got it. Hmm. (1920 by 1200). Well, it's mirroring now, which is better. How does that actually look on stream? Let me have a look. I think we got it, but we have got the bonkers thing of there's two polybars going on. I don't really know why. And yeah, the resolution's not great. And I don't know why the background's gone wonky. Like the background's just gone completely like. Let me copy this. Put that into the Okay. Oops. It's mirror by default. Okay, we're going to come back here again. We're going to run our getter thing. Just wonder if this will fix the issue. Whoop. Just a little bit of teething problems getting started with this. I'm just going to zoom in for now, but I want to update my UI preferences on Linux to a little bit be more zoomed in. It's going to like disappear in a second. Dashboard. I think they changed the UI a bit actually, because this looks a bit different. It should be on here. Get that page ready. I'm just going to wait for this. Basically, I just have this dot file scripts now that will basically just what do you call it? Set the computer up from scratch with everything that I want installed. It's a work in progress. It's not complete. Like all the themes that I want, i3 configured and stuff. But as you can see, for some reason, I've got 2 polybars. I'm not really sure why. This was working last time, but I'll just try and ignore it for this one. Get started, and we'll get on with the course, because that's what we're here for. So let's just wait for this to finish. And we'll be ready to go. Another thing we might run into if there's videos, I haven't set up headphones, my Bluetooth headphones with this laptop, so that'll be fun. We'll figure that out. Still getting used to Linux setup again, but I like it. There we go. Picture's gone back to normal. Big blue square though, I can't really show what that's doing. This might be the screen, better lock screen stuff, kind of doing stuff. I might just ditch that, because that was mainly just to get over the hump of like when the lock screen first came up for i3, it just completely threw me off. I was like, how the heck am I supposed to do anything on here? You know, it's really threw me off. Are we back to normal? Well, apart from the double thing going on here, we're back to normal. Yeah, there we go. Okay, right, let's get stuck in, because we're wasting enough time with this anyway. We'll probably do another night of like probably do more things of getting this set up. Like we haven't got Vim set up either yet properly, so it's going to be a lot of humps and bumps, like, you know, going through this, but we'll manage. Anyway, let's start the course and go from there, because it's been a while. Awesome. Right, we'll have a terminal if we need one. Yep, and away we go. So, what is functional programming? Finally, we can start the video. Sorted out all the guffs and stuff, and we've got 39% battery left, so I better plug in, because I got a feeling I'll just forget and it'll shut off. So let's do that. I do like this laptop. Really, really like it. Just getting used to just being on Linux again and things being a little bit difficult in terms of setup. Yeah, I just wish that was gone. Anyway, we'll clean it up. So, what is functional programming? Functional programming is a style or paradigm, if you're pretentious, of programming where we compose functions instead of mutating state, updating the value of variables. Functional programming is more about declaring what you want to happen rather than how you want it to happen. Imperative or procedural programming declares both the what and the how. For example of imperative code. Car equals create car. Car.add gas 10, and then car.clean windows. Example of functional code. Clean windows, add gas, create car. So create car comes first, then you add the gas, then you clean the windows, you go inside out. The important distinction is that the functional example, we never change the value of the car variable. We just compose functions that return new values with the outermost function, clean windows in this case returning the final result. Doc to doc. In this course we're working on doc to doc, a command line tool for converting documents from one format to another. If you're familiar with pandoc, the idea is similar. Assignment. Complete the stylized title function. It should take a single string as an input and return a single string as an output. The return string should have both the title centered and a border added. The return string should have both the title centered and a border added. Use the provided functions center title and add border. Center the title before adding the border. Do not create any variables. Use only one line of code in the function body. So don't touch below this line. That's fine. So stylized title function. Take a single string as an input and return single string as an output. So use the provided function, center title, add border, center the title before adding the border. So we're going to do return title. I'm going to give it the document. And then around this, I'm going to do add border. I think that is it. Oh, come on. Yep, I think that's it. So Control Shift Enter. Hooray! What's to go to the next one? Control dot. Yeah, I'm going to start using keyboard more. Excuse me. So it says, why Python? Frankly, Python is not the best language for functional programming. Reasons include no static typing, almost everything is mutable, no tail call optimization, side effects are common, imperative and object-oriented styles abound in popular libraries. Purity is not enforced and sometimes not even encouraged. Some types are hard to define. Pattern matching is weak at best. So seriously, why are we using Python? One reason trumps all others. You already know Python. Python is a great choice for learning coding basics, object-oriented programming, algorithms, and data structures. And the trade-off of learning a new language at this point in the curriculum isn't worth it. That's fair enough. We can still cover the most important concepts of functional programming in Python, even if we have to jump through a hoop or two to do it. Functional programming is a paradigm of useful techniques for writing better code, and they apply to all languages, not just purely functional ones. We also plan to release a functional programming 2 course in a more functional language, likely one of these, Haskell or Camel or Elixir. Why learn functional programming in Python? Because we already know it. Because values are immutable. That's that one. Because we already know. Immutability. In functional programming, we strive to make data immutable. Once a value is created, it cannot be changed. Mutable data, on the other hand, can be changed after it's created. Who cares? Let me just have a look at how many things in this. Okay, like 14, and there's like 9 chapters. Yeah, nice, okay. Yep, we'll make through quite a bit of progress tonight. In functional programming, we strive to make data immutable. Once we create a value, once a value is created, it cannot be changed. Mutable data, on the other hand, can be changed after it's created. Who cares? Immutable data is easy to think about and work with. When 10 different functions have access to the same variable, and you're debugging a problem with that variable, you have to consider the possibility that any of those functions could have changed the value. When a variable is immutable, you can be sure that it hasn't changed since it was created. It's a hell of a lot easier to work with. Generally speaking, immutability means fewer bugs and more maintainable code. I agree. Tuples versus lists. Tuples and lists are both ordered collections of values, but tuples are immutable and lists are mutable. You can append to a list, but you cannot append to a tuple. You can create a new copy of a tuple using values from an existing tuple, but you can't change the existing tuple. So lists are mutable. So ages is being changed in place. You just like append and just add 1, 1. Tuples are immutable. So more ages. Note the comma. It's required for a single element tuple. All ages is a brand new tuple. All ages plus more ages is that you can't change. Once that's set. Assignment. The add prefix function accepts 2 arguments. Document, a string, documents, the current tuple of strings. It should do 2 things. Add a prefix of x dot to the beginning of the new document, where x is the next index in the tuple. The first document should be 0 dot, then it should be 1, 0, etc. Return the document's tuple with the new document added to the end. Run the code to see the error. Whoever wrote this code assumed that documents is a list, but it's a tuple. Fix the bug. Instead of attempting to mutate the input tuple, create a brand new tuple with the new document added to the end and return that. So we run that, squid this up a little bit. So what's it doing? It's got documents, prefix. So it tries to get the length of the documents and then, 4 strings it. Excuse me. So the new document is the prefix plus the document. And then documents dot append new doc. So documents, hello there, how are you doing? Expecting that actual error, the tuple object cannot be there's no attribute to append. Run the code, see there, fix the bug. Instead of attempting to mutate the input tuple, create a brand new tuple with the new document added and return that. So I'm going to call this all documents. Oh wait, hold on, we do underscores, don't we? In Python. So I'm going to say all underscore documents equals like this. And how do we run? Control enter. Nope. If I put it in can only concatenate tuple, not string to tuple. Documents. Why is documents then? Oh. Okay. Yay! Dunzo. Haha. Right. So we got video. Now I'm going to need to work out how I connect my headphones. Hold on now. Hold on. i3wm connect to headphones. I'm going to take this off for a second. Hold on. Try and get this. Just trying to figure this out. I'm going to try something a little different. So I'm going to share the laptop screen, and I'm just going to see how the. So I'm going to unmute. I'm going to play it. Right, so it doesn't capture the audio through that. I'm gonna try this and see what. Oh, just looking at how audio's been doing. Right. I think what I'll probably have to do is I'll probably just have to listen to this and then figure out for next time for you guys.
But I'd argue that the main purpose of functional programming is to make our code more declarative. CSS, I know, disgusting, is actually a great example of declarative language. Take a look at a simple snippet of CSS that turns the color of a button red. There are no step-by-step procedures. We simply declare, I want buttons to be red. The browser then takes that change and implements it. It applies it so that all the buttons on the website are rendered right on the screen. Now let's take a look at a similar example that's implemented in procedural, non-declarative Python. First, we get right into the nitty-gritty of the implementation details by importing the tkinter library. Next, we'll create a new GUI window. We'll set the size of the window. We draw a red button on the screen. And finally, we call the main loop that keeps the window open and listens for any incoming events. The key difference here is that in the procedural Python example, we're very concerned about the how in addition to the what. When we're writing declarative code, you really just want to worry about what. Want. Mathematics is another great example of declarative. And that's why functional programming is often more popular with mathematicians. Take a look at this equation. X equals 7 times 10 plus 6 times 11. The equation doesn't tell us in which order we need to carry out each computation on our hardware. And it also doesn't tell us exactly where we should store each value in the memory on our computer. We could write this way, or we could swap the ordering around like this, and we get the same result either way. Functional code is mostly a pipe dream because at the end of the day, somewhere we need to specify how to get stuff done. But we can continuously try to make our code more and more declarative, which means more and more functional, by hiding the implementation details at a lower level. So the goal of the functional programming style is to bring us closer and closer to this declarative activity.
Okey-doke. So you might have heard a little bit of that through the speaker. We'll figure this out for next time, but basically just describing declarative versus imperative. So functional programming aims to be declarative. We prefer to declare what we want the computer to do rather than muck around with the details of how to do it. Let's take an extreme example and pretend we wanted to style a web page with CSS. Obviously a hypothetical because, well, why would anyone want to work on the front end? Declarative styling. So the following, the following CSS changes all button elements to have red text. So button color red. It does not execute line by line like imperative language. Instead, it simply declares the desired style, and it's up to a web browser to figure out how to apply and display it. Imperative styling. Unlike functional programming and CSS, a lot of code is imperative. We write out the exact step-by-step implementation details. This Python script draws a red button on a screen using the Tinker library. And explain that. So CSS is typically declarative. Yay! Oh, same again. A script that does one thing after another is imperative. Yay! Okay, so it's math. Functional programming tends to be popular amongst developers with a strong mathematical background. After all, a math equation isn't procedural, it's declarative. Take the following math equation. Average equals sum x divided by n. To put this calculation in plain English, this character is just the Greek letter for sigma and represents the sum of a collection. X is the collection of numbers we're averaging. N is the number of elements in the collection. Average is equal to the sum of all the numbers. Average is equal to the sum of all the numbers in collection X divided by the number of elements in collection X. So the equation really just says that average is the average of all numbers in collection X. This math equation is a declarative way of writing. Calculate the average of a list of numbers. Here's some imperative Python that does the same thing. So get average. So nums total equals 0 for each for num in nums total plus equals num. Return total divided by the length of nums. However, the functional programming with functional programming, we'd write code that's a bit more declarative. So we'd have a function called sum of the numbers divided by length of the numbers. Here we're not keeping track of the state. The total variable in the first example is stateful. We're simply composing functions together to get the result we want. Assignment. In the world of document conversion, we sometimes need to handle fonts and font sizes. Complete the get median font size function. Given a list of numbers representing font sizes, return the median of the list. Wow, excuse me. Complete the get median font size function. Given a list of numbers representing font sizes, return the median of the list. For example, 1, 2, 3 is 7, 10, 8, 7, 5 is 7. Notice the second list is out of order. Order the list, then find the middle index and return the middle number. If there is an even amount of numbers, return the small of the two middle numbers. I know this is not a true median, but for our purposes, if the list is empty, just return none. Here are some helpful docs. Sorted, length, and floor division. To be a good little functional programmer, your code for this lesson should not use loops, mutate any variables. It's okay to create new ones. Okay? We're going to find the median of these. So font sizes. So let's have a look at the sorted thing. Sorted takes an iterable, key non-reversible. Okay, so I think we could just do sorted underscore font underscore sizes equals sorted font sizes. And then just for now, we'll do return sorted font sizes. Just see what it does. Obviously it all fails, but that's just kind of as we expect. So it puts them into order, and then we want to get the length. So then we're going to say median. Median equals sorted font sizes. And then it's like I think it's like brackets like that, and then we do like length font sizes, actually like that, and then run it again. Whoops. I've forgotten how we reference an index array. Hold on. Up again, so array. List in Python, let me look again. So pop. So I think we're going to have something else. So we're going to have middle index equals this. Oh, whoops, I went the wrong way. Go back. And to control enter. Floor division. Yeah, 2.5. Yeah. So print. Probably just doing something silly, but I'm just checking my work. So length is 5. So divided by 2 and floor it. Now why it's failing, it's basically getting 2 here. The index of that. So for this example, it gets 4, that's divided by 2, so it's 2, gets the index of 2. This one's 3. And it's 1.5. But it can't do that, so it takes 1 and that. The thing that's throwing me off is what's the best way of sort of telling if like it's like an odd number or whatnot. So I guess middle index. Wait, hold on. Array is odd equals Python check for odd number. It's like the modular thing, the bitwise operator. I bet it doesn't need this. I bet it's just like much simpler. So we do sorted. Then we get the length of this and then divided by 2. But floor it if it's a, if it's a decimal. But that doesn't work for this one. Huh. Okay. Just seems a bit long-winded to be like doing something wrong. Hold on. It's this one. So this one is going to be 2. I feel like it shouldn't be stumping me, but like without making it really messy and like trying to keep it functional, I'm not sure how to do that. No loops, no mutating variables. I'm going to ask Boots. I know I need to get the middle text, but how do I use the for operator to deal with even numbered lists? I'll feed him that salmon. When you're working with the median calculation, we need to handle both odd and even lengths lists differently. There's not going to be a magic bullet. I thought there would be. The for division operator can help us elegantly find the correct index. For odd length lists, the median is simply the middle element. For example, in a list of 5, the median is at index 2 from a 0 index base. For an even length list, the instructions ask us to return the smaller 2 middle elements. This is where the for division shines. Here's how the math works. So for a list length of 5, okay. So it's going to be this, what I was doing before, but it's in the wrong place, basically. I need to put that in brackets, probably. Yeah, okay. Yeah, I was on the right track before. Okay. Whoops. Okay, so sorted font sizes len equals that, and then basically if hold on, if sorted length is is equal to 0, then return none. Oh no, still failed. Expected actual none. Expected actual. Right, this is not just a simple example of this. Ah, forgot to paste the source font sizes length. Whoopsie daisy. There we go. Huzzah. Let me have a look at the solution. Oh, they just do it all in one go. So if length font size is like that, blah blah blah. Yeah, they go straight for it. Okay, I wouldn't write it like that, but if it is. So classes versus functions. Classes versus functions. I run into new developers who, after learning about classes, want to use them everywhere. They assume that because they learned about functions first, functions are somehow inferior. Nope, they're just different. Should I use functions or classes? Here's my rule of thumb. If you're unsure, you default to functions. I find myself reaching for classes where I need something long-lived and stateful that would be easier to model if I could share behavior and data structure via inheritance. This is often the case for video games, simulations, GUIs. The difference is, classes encourage you to think about the world as a hierarchical collection of objects. Objects bundle different behavior, data, and state together in a way that draws boundaries between instances of things like chess pieces on a board. Functions encourage you to think about the world as a series of data transformations. Functions take data as input and return a transformed output. For example, a function might take the entire state of a chessboard and a move as inputs and return the new state of the board as output. Yeah. Okay, which is better? They're good in their own special ways. Which encourages you to break down problems into instances of stateful things? Classes. Okay, debugging functional programming. It's nearly impossible, even for tenured senior developers, to write perfect code the first time. That's why debugging is such an important skill. The trouble is, sometimes you have these elegant, sarcasm extended one-liners that are tricky to debug. So things like, we'll even start reading it. So calc move, calc friction, calc gravity. If the output of get player position is incorrect, it's hard to know what's going on inside the black box. Break it up. Then you can inspect the moved, slowed, final variables more easily. So moved, slowed, final, given, blah, 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 blah. Yeah. Once you've run it, found the issue and solved it, you can remove the print statements. Assignment. Fix the format line function. It should apply the following transformations in order. So if I... it should strip white space. So what we're going to do is we're going to do stripped of white space equals that's going to be line dot r strip. And then we're going to do capitalize every character in the line. So capitalize every character in the line. Capitalize every character equals stripped of white space dot capital capitalize remove any periods from the line. So remove periods equals capitalize every character dot replace place, and then it's going to be any periods from the line. So that's the wrong thing. So it's going to be like dot like that, and then suffix the line with an ellipsis. Words go here. So final string equals remove periods plus and then what was it? Words go here. Words go here. Dot dot dot. Then we're going to return final string. Return final string. Suffix the line with the ellipsis. Oh, took that literally, just like that. Okay, so expected actual, you can't spell America without Erica. Blah, blah, blah. Run the code, you should see that some sort of bugs are present. Break up the function, make it easy to debug. Use print statements to see what's going on in each step. Tips. Be careful about white space, it's easy to miss in the console output. I sometimes add a character like pipe to the beginning and end of a string to make white space more obvious when print. Replace can be used to replace all instances of a character in a string. Upper capitalizes the entire string, capitalize the first letter. What do we want to do? Capitalize every character in the line. So we want to do upper. Strip removes white space from the beginning and end of the string. L strip and R strip remove white space from left to right respectively. So they kind of give us like the functions that I didn't really remember understand and stuff. So that should basically do it. Like that. Boom. It kind of tricked us a little bit. Functional versus object orientated. Functional versus object orientated. How many chapters do we got of this? Yeah, I think we could get through maybe 2 tonight, hopefully. Functional programming, object oriented programming styles for writing code. One isn't inherently superior to the other, but to be a well-rounded developer, you should understand both well and use ideas from each when appropriate. You'll encounter developers who love functional programming, others who love object-oriented programming. However, contrary to the popular opinion, functional and object-oriented programming are not always at odds with one another. They aren't opposites. Of the 4 pillars of object-oriented, inheritance is the only one that doesn't fit in functional programming. So encapsulation, abstraction, polymorphism, inheritance doesn't fit that. Inheritance isn't seen in functional code due to the mutable classes that come along with it. Encapsulation, polymorphism, and abstraction are still used all the time in functional programming. When working in a language that supports ideas of functional programming, object-oriented programming like Python, JavaScript, and Go, the best developers are the ones who can use the best ideas from both paradigms effectively and appropriately. Functional and object-oriented programming are all about writing faster code, writing code that uses less memory, writing code that runs on any machine, writing cleaner code. It's always about the clean code. Object-oriented programming's concept of blank conflicts with functional programming and its inheritance. Boop, boop. Here we go. So we've got 3 challenges in this one. Let's see how we do. We've got about an hour and a half left. So toggle case. We need to add a feature to doc that switches the capitalization of all the words in a line. Assignment. Complete the toggle case function using string methods. It takes a string as input line and returns a string. If line is in title case, convert it to all uppercase and add 3 exclamation marks to the end. Okay. Okay, so this one's kind of easy. Whoops. So the end, otherwise return line. So return line dot, and then it's upper plus, and then it was then the next one. So is supper. If the line is all uppercase, convert it all to lowercase except the first letter and remove the trailing. So return, and then it's going to be a line except for the first letter. So capitalize. Let's see what that does. See if it does what I'm expecting. Actual be milk boots, and remove the last thing. So then how do you strip stuff out of the if the line is all lowercase or only the first letter is capitalized, convert it to tile case. To tile case. And then return line. Return line. This one's if line is lowercase, first create tile case dot I don't know all the methods. So case fold center count is the title case. Nice. So title. And then how do I strip remove all trailing exclamation marks? So remove. I suppose I can do like replace or whatever. Strip. Remove. So strip. Then right strip like that. Okay, I think that's all correct. Yay! What was that solution? Was ours any different? Yeah, it kind of just did the same. Yeah, it's the same. Happy days. Debug hex to RGB. Doc should seamlessly convert hex triplet color codes to RGB values. Hex colors are an efficient means of representing color with only 6 characters. RGB values combine red, green, and blue light to electronically display the entire color spectrum. Assignment. Debug the hex to RGB function. Hex to RGB should take a hex triplet color code and return 3 integers for the RGB values using. Should return the 3 integers for the RGB values using int. One of the arguments used in the int is incorrect. Examine the documentation to see how to convert hexadecimal values. Use the provided is hexadecimal function inside hex to RGB to check if its input is valid. If the input is not a 6 character long hexadecimal string, raise an exception, not a hex color string. Example. Okay, let's just run this to see what it does. Okay. Okay. Don't edit below this line. RGB, so hex color. What's wrong with this? So invalid literal for int. One of the arguments for int is incorrect. Int. What? So int takes a number in a base of 10. Do you even need that? Okay, do you need that? Whoops. What's incorrect? Hex color. One of the arguments used in int is incorrect. So this is like not 2 to 4 to 2 to 4, 4 to 6, is that right? Whoops, no, not go forwards. Yeah. One of the arguments using int is incorrect. Examine documentation to see how to convert hexadecimal values. User provided is hexadecimal. Oh, right, okay, I see. Is hexadecimal inputs, hello, okay. FF. Input's valid if the input is not 6, raise an exception of not this. Okay, right, okay, I see. So I didn't really pay attention to that. So this. So if is not hexadecimal hex color, then raise. I've forgotten the syntax. It was like raise exception. And then it was not a hex color string. No, that wasn't the. This is a tricky bit. So A0 is hexadecimal. Returns an integer object constructed from a number or a string to return 0 if no arguments are given. If argument in returns blah 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 blah, if argument is not a number or a base is given, then it must be a string. So what's the problem here? Examine the documentation to see how to convert hexadecimal values. Hi, hold on, I realise. I think it's this. It says it wants to be base 16. Almost got it. So one failed. Inputs 42, not a hex close string. Actual error, invalid literal for in base 16 like that. Okay. Or X color. I think we just do like a length. So like length is less than 6. Right, I don't think this is fully right, but it worked. Let's see how different theirs was. So they did the same basically. If not, they put the not at the beginning, right? Okay, it's right. I'll try and remember that with Python. So put the not at the beginning. If not, it's hexadecimal or length is less than that. Blah blah blah. Yeah. So and they changed it to base 16. So that's cool. We did that. Yep, correct. On to the next one. Last challenge in this one, and then we'll get into the second part. So dedupe, this is an optional challenge. You skip to the next chapter if you want. We do this. Dedupe lists. So we need to add a feature to doc The merges two lists of items, removes any duplicates, and returns a sorted list of unique items. This is important for consolidating certain documents and metadata. Merges two lists of items, removes any duplicates, and returns a sorted list of unique items. It's important for consolidating certain documents and metadata. Assignment. Complete the deduplicate lists function. It takes two lists as input, list 1 and list 2. And an optional reverse boolean, and returns a sorted list of unique elements. And an optional reverse boolean, and returns a sorted list of unique elements. If reverse is true, then the list should be sorted into descending order using sorted and pass it in the reverse parameter. Okay. God, I'm just testing my knowledge of like remembering a Python now. I don't really remember. So I guess we can have like a joined list equals list 1 plus list 2, and we just return. But now we just return a joined list. So it's just doing what I expect. Actual. Yep. So it does do that. Tip. So it takes an initial and argument, always returns a list. Sorted. And then sorted list plus sorted. That's going to be joined list, comma, reverse. That's going to be sorted list. Yeah, I thought this takes a parameter. Hold on. This one, list to expected, actual. Oops, no, not that. Hold on. Let me have a look at sorted. Sorted. Python sorted. And can you just put a, I don't know if you can do this, can I just put a comma like that? Key none. Expected one argument got 3. What? See some examples. Sorted. Iterable key function reverse equals true. Hmm. I can get the wrong end of the stick with this, like sorted. Return a new sorted list from the items iterable. Has 2 optional arguments and must be specified as keyword arguments. Oh, right, I see. So it's going to be, what was it? Key equals none, and then reverse equals reverse. Is that right? Reverse equals reverse. Is that why? Must be special keyword arguments. Yes. Right, so first example we got there, but we just need to dedupe them. So how do we do that? Dedupe unique. Is there a smart way of doing this, or is it just a case of dedupe? Is it map or dicts? It's not really dict though, is it? Like lists. Just use a set? Yeah, I guess so. Unique. Unique list. Equals set. And sorted list. Unique list. Unique set, and then we're going to do oh wait, hold on, unique list set, and then turn it back into list again. List, and then it's going to be like that, and it's going to be sorted list like that. Okay, I think that's it. Hey, what do they do as their solution? Oh yeah, they did the same thing, but they did it in a one-liner. Nice. Boom. Chapter 1 done. Blimey, that was a bit of a struggle. So we've got another hour left. We're only on to chapter 2. That was a bit of a struggle, that. We did lose a lot of time at the beginning. How many lessons we got in chapter 2? Same amount. So let's see if in the next hour we can get through this. And we'll be all hunky-dory. Let's have a look on chat. Just see how things are going here. Anyone chatting? Anyone chilling? Yep. Nobody really online, but that's fine. We're doing this for the fun of it. So, chapter 2, which is going to be first class functions. We've got 12 lessons, well, 9 lessons and 3 challenges to get to. So let's see how we do. So functions as values. In Python, functions are just values, like strings, integers, or objects. For example, we can assign an existing function to a variable. Functions are just values, like strings, integers, or objects. For example, we can assign an existing function to a variable. Yep, so add. Assign the function to a new variable. Call addition, it behaves the same as the original add function. Assignment. With the popularity of generative AI like ChatGPT, we need to be able to convert files into pure text to be injected into prompts. Complete the file to prompt function. It should take a file dictionary and a toString function as inputs and return a formatted string. The provided toString function is responsible for converting the file dictionary into a string. You don't need to implement it. It's a value passed to your function. Complete the file to prompt function. It should take a file and toString function as inputs and return a formatted string. Excuse me. The provided toString function is responsible for converting the file dictionary into a string. You don't need to implement it. It's a value passed to your function. However, your function should wrap the result of the toString function in triple backticks to format it as a code block in Markdown, for example. Okay, so we should return. How do I do that as a thing? F string. I've forgotten how it goes. So like the F string thing, and then is it like where backticks on this keyboard? It's like that F string, and it's going to be 1, 2, 3. And then 1, 2, 3, and then what was it again? Like this, like that. Can't remember, roughly like that. And it's going to be a toString file. Run that. Whap. I've forgotten how to use F strings. Hold on. Notice the 2 lines in the example above. You don't need a trailing new line, but you do need 2 new lines between the big triple backticks. You can achieve this with the new line escape character as example. Print. So, hold on. And then \n, and then \n. We don't need the thing. Okay, got it. Submit it. Ooh, yeah. Anonymous functions. Anonymous functions have no name, and in Python they're called lambda functions after lambda calculus. Here's a lambda function that takes a single argument x and returns a result of x plus 1. Notice that the expression x plus 1 is returned automatically. No need for a return statement. That's because functions are just values. We can assign the function to a variable named add1. Add1 is that lambda x, x1. Lambda functions might look scary, but they're still just functions because they simply return the result of an expression. They're often used for small, simple evaluations. Here's an example that uses a lambda to get a value from a dictionary. So lambda name takes the name attribute, and takes get age, takes the name as the object, get name not found. So get age, and then you give it lane, and it'll look up in this. Complete the file type getter function. This function accepts a list of tuples where each tuple contains a file type, e.g. code, document, image, a list of associated file extensions, e.g. .py, .js, or .docx or .doc. First, use loops to create a dictionary that maps. Each file extension to the corresponding file type based on the input tuples. For example, the resulting dictionary might be. Next, return a lambda function accepts a string. Oh gosh. First, use loops to create a dictionary that maps each file extension to its corresponding file type. Oh god, now I'm like can't even remember the simple stuff. So file extension in file extension tuples. Print. Let's just print it out. Start with like file extension. See what it does. First, use loops to create a dictionary that maps each file extension to its corresponding file type. For example, the resulting dictionary might look like this. Next, return a lambda function accepts a Next, return a lambda function that accepts a string. Next, return a lambda function that accepts a string. A file extension returns the corresponding file type. If the extension is not found in the dictionary, the lambda should return unknown. I used the .get dictionary method to handle this. So I guess this will be, we'll have to have a dictionary then. So for each to create a dictionary maps each file extension. So mapped file extension dictionary equals that, I guess. And then we do well, how do we do that? Like so then we're going to have file type equals file extension. Let's change that to tuple. File extension tuples to tuple. File extension. Let's go tuple like 0. And then list of file list associated, so like associated extensions. Let's file extension tuple 1. We print. Could we print that file type? Okay. So I'm going to be. I've forgotten everything now. It's been so long. Like I guess. So file extension dictionary. Hold on, I've completely forgotten dictionaries. Hold on. Dictionary, Python dictionaries. Can I just do like that? So like I can just do file extension dictionary, file type. Hold on. So for associated extension in associated extensions, we do file extension dictionary. We do associated extension equals file type. And then let's just run it and see what it does. If we just go print, I guess like return file extension dictionary. Or just print it, so print file extension dictionary. So we have got that. So I think we managed to do that part. The right way around. Yeah, it's the right way around. And then next return a lambda function that accepts a string. Okay, so oops. So then we want to return lambda accepts what? File score file extension. What's the syntax? So file extension file extension dictionary dot get file extension how's that method work? Hold on. Return the default value for the key. If key is in dictionary, else default. All right. There we go. Managed to do it. Let's submit. Ctrl Shift Enter. Yay! So have a look at their solution, see if it's any different. Yeah, they did it a lot more simpler than me. So they set up a dictionary like I did, and then for the same thing, started with like file extension tuples for each tup, and they just went straight into another for each. So each tup, like in the first part, blah blah blah. They just shortened up basically what I already did, which is kind of cool. No props. No props. So we're on to lesson 3. First class and higher order functions. A programming language supports first class functions when functions are treated like any other variable. That means functions can be passed as arguments to other functions, can be returned by other functions, and can be assigned to variables. supports first class function when functions are treated like any other variable. That means functions can be passed as arguments to other functions, can be returned by other functions, and can be assigned to variables. First class functions, a function that is treated like any other value. Higher order functions, a function that accepts another function as an argument or returns a function. Python supports first class and higher order functions. So first class example. So define a square x, so return that. Assign function to a variable. F does the same thing, 25 just runs it through that. Higher order function example. Function exception, function returns a function. So square, so x return x, that returns the result. Define my map. So my map takes a function and an argument list. Result is an array or a list, I guess. And for each argument in the list, it appends the result of that function to that. So my map, it takes a square function, squares, print squares, square. Function accepts another function as an argument or returns a function. Oh, a higher order function is a function that accepts another function as an argument or returns a function. Right, where's a function that returns another function? Higher order function. Which is the higher order function in the second example? My map. Okay. Lesson 5. Map. Filter, reduce, map, filter, reduce. Cool. Intersect, zip, restore. Okay, some proper challenging ones here. So, map, filter, and reduce are 3 commonly used higher order functions in functional programming. In Python, the built-in map function takes a function and an iterable, in this case a list, as inputs. It returns an iterator that applies the function to every item yielding the results. Yep, so add hello. With map, we can operate on lists without using loops and nasty stateful variables. For example, define square, return x times x, so nums, list 1 to 5. Square nums, we can map. We can use squares, the function, and run that function on each entry. And we'll print the list of squared numbers. The list type constructor list converts the map object back to a standard list. Okay. Assignment. Markdown supports 2 different styles of bullet points. Dash and asterisk. We prefer asterisk, so we need a function to convert any dash bullet points to asterisk bullet points. Complete the change bullet style function. It takes a document as a string as input and returns a single string as an output. The return string should have any lines that start with a dash character replaced with a asterisk character. For example, this is a bullet becomes this is a bullet. Use the built-in map function to apply the provided convert line function to each line of the input. Use split and join to split the document into a list of lines. Then join the lines back together. This should preserve the original line breaks. Don't use replace string method. Examples of split join, select split by that. Rejoined. Okay, so I edit below this line. So my gut feel tells me. So we're going to return map, and we're going to use convert line on the document, and let's just see what it does off the bat. Just doing that, see what we got on our hands basically. Initial call expect output. dot split. It's going to be a new line. Whoops, where's my characters? Hold on a second. So we're going to have document lines equals this document split like that. Document lines list. It's going to be document lines list and just see what this does. Nothing. And we're going to be hold on. Maps. Let's go to document. What's that? And we're going to do return. Oops, return at document dot join Wow, that was pretty simple. What was their solution? They do it in one line? Yeah, they did. Yeah, that's fine. Okie dokie. So we did that. So filter. The built-in filter function takes a function, an iterable, in this case a list, and returns an iterator that only contains elements from the original iterable, where the result of the function on that item return true. So in Python, like the definition of is even, take x modulo 2 equals 0 is even. Take a list of numbers 1 to 6, make the filter is even against the numbers, and then put it back into a list and print evens. Complete the remove invalid lines function. It accepts a document as input, and it should use the built-in filter function and a lambda to return a copy of the input document. Use a filter function and a lambda to return a copy of the input function. Remove any lines that start with dash character. Keep all the lines and preserve trailing new lines. For example, okay, so we're going to have split document equals document dot split by the new line, so like /n, and then remove any line that starts with a dash character. So then removed dashed lines equals list filter. We're going to pass it split document, and use built-in filter function and a lambda to return a copy of the input document. Um, keep all the lines preserving, trailing new lines. I don't get this bit, like, how do I use the filter function when I don't have another function to use it for, unless I'm allowed to add one. So, I guess, define is dashed line. And we take a line, and then if line, find how you check this, so like Python check if string starts with, I can't know how to do that. Whoops. Yeah, go away. Starts with hello. Okay. Line dot starts with, and then if we give it I guess a dash space, then return true, else, the L, can't remember else, is this else like that? Else return false, false. So it is dashed line, we give it the, actually no, just like that, and then I guess what we can do is just test it. We can test return removed dashed lines and just see what it does. Can only concatenate string, not list to string. I guess let's do it like that for now. Probably just misunderstanding what I'm doing. Not filter to string. Python error trace back. So can only concatenate string. So file execute line 6. In module line 16, blah 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 blah, and test expected actual output input, expected actual. Print split document. So then we print removed dash lines and just see what that does. Filter object. I'm going to change it so it is asterisk line is asterisk line like that. Okay. And then I guess dot join. It's going to be like that again, so like new. Is dashed line. Remove dashed remove dashed line. Yeah. So it works, but I want to see their solution because they probably have a little bit more elegant. Are you kidding me? I can do a lambda function, but I did the rest of it. They just did it in one line. Crazy. So they just returned join filter lambda line. Not line starts with it on the same thing, so not line starts with document split. Wow, they can ravel up code very, very, very neatly. I'll get there at some point. Oh, God, this I don't remember the object oriented one being this sort of big, but anyway, reduce. So built-in functools.reduce function takes a function and a list of values and applies the function to each value in the list, accumulating a single result as it goes. So reduce, concatenating the words list. Just keep, swimming, just keep swimming, exclamation mark. So import functools from the standard library. Import functools, definition add sum so far, x print, f sum so far, blah 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 blah. Okay. So numbers. Some functions reduce, add, and numbers. So sum so far, x. And notice that we are passing the function add without the brackets. It means that reduce will take care of the execution and pass the parameter for you. Think of passing add like handling someone a recipe, the instructions instead of the finished dish, the result of the execution. Assignment. Complete the join and the join first sentences functions. Join. This is a helper function we'll use in join first sentences to take it takes two inputs. In fact, hold on a second. Got something to check. I think we're going to have to leave it there for tonight. Just looking at the time for things, I've got something I need to do. And I need to figure out what the heck's wrong with the laptop next time, but that ain't no pressure, just some nicety thing to get done. Yeah, I think we're going to wrap it up for tonight. Got to lesson 7, chapter 2 of this, so we're doing all right so far. We'll smash through the rest of it. Quite a lot of chapters. I'm thinking these might be a little bit shorter, but we'll see when we go through them. But anyway, so I thank you for coming down. I hope you've had, I hope you enjoyed it. I hope you had a little bit of fun, learned something like along the way. You come back tomorrow night and Thursday night and stuff where we'll be smashing through more of the functional course part. And yeah, stay safe. Have a good night and